In this video, we're going to be introducing the concept of eliminating the parameter. To eliminate the parameter is exactly what the name implies. What we're going to do is use a combination of substitution, elimination, or other identities to eliminate t from our equation. Now, when we are dealing with these parametric equations, we're going to have two equations involving three variables. The three variables are t, x, and y, normally given as x is going to be some function of t, and y is going to be some function of t. The goal is that we would like to eliminate the parameter t and wind up with something in terms of just x and y. Now, what we typically wind up with here is a relation rather than an actual function, which is why I'm not using a notation like f of x or f of y or g of y or anything along those lines. Now, because we've covered substitution and elimination in previous classes, let's talk about how to use them here. So the previous example that we had just gone through was x is equal to t squared minus 6t plus 1. And we also had y is equal to t minus 2. And the given parameter is that t was going from 1 to 5. Now again, we can either use substitution, elimination, or some other identity to try to get rid of t. Based on what I'm seeing here, I don't really feel like solving this for t because that would involve completing the square, and I'm just not feeling it today. This one though, oh, this looks great as far as solving for t. So what I'm going to do is solve for t here. I can do so relatively easily by adding 2 to both sides. Hi, cutie pie. Oh yeah, she needs snackies, I guess. Then I'm going to take this expression for t, and I'm going to be plugging it back in to my expression for x. Substitute. T is equal to y plus 2. And if we substitute t is equal to y plus 2, we're going to get x is equal to, this will become y plus 2 quantity squared minus 6 times y plus 2 plus 1. Now technically at this point we are done eliminating the parameter. However, if you wanted to expand and then combine like terms, you could certainly do so. Expanding the y plus 2 quantity squared, that'll be y squared plus 4y plus 4. Distributing the minus 6, we'll get minus 6y minus 12 and plus 1. Combining all of our like terms that I see here, this will be y squared. Combine those two together, we'll get minus 2y. And then combining all the constants together, I'm seeing a negative 7. Now, in the event that you were interested in completing the square on this, we could also show that this would become y minus 1 quantity squared minus 8. Again, relying on your ability to complete the square there. Now, if you'll kindly recall, when we had put this thing together, we got a parabola that opened to the right with a vertex at the ordered pair negative 8, comma 1. And hopefully seeing the standard form here allows us to draw the same conclusion. This is a parabola. It's going to open to the right, opens right, with a vertex at x equals negative 8 and y equals positive 1. Now with that in mind, we also were only talking about one portion of the parabola, specifically the part where t goes from 1 to 5. Now with that in mind, if I were to plug t goes from 1 to 5 in for the y value here, what we could do is come up with the appropriate range. So the range of the given function, if we plug in t equals 1, we get a lower bound of negative 1. very similar to what we would do for a u substitution when we're integrating. For the upper bound t equals 5, we plug it in and we get 3. Now once you have the range, and because you have x as a function of y, the range is all that you'll need to figure out what the appropriate part of the graph would be. Now what I'd like to do is have us consider a secondary example. And the secondary example that I wanted to have us take a look at will be the following set of parametrics. So let's do x is equal to e raised to the t power, and y is equal to e raised to the 2t power, where t is going to be any real number. Now, once again, you are completely capable of using whatever technique is necessary to eliminate the parameter. What I want to point out, though, is that because the relation is e to the t and e to the 2t, what I'm going to do is try to get this to become an e to the 2t. I can do so by squaring both sides. If we get x squared is equal to e to the t quantity squared, when you have a base raised to a power that is in turn raised to a power, we would get e to the 2t. Which, as we just said up above, e to the 2t is equal to y. As a result, we would be looking at a portion of the graph y is equal to x squared. Now it's been pointed out that t can be any real number. However, x and y, that doesn't necessarily mean that they are going to be any real number. Do keep in mind that the range of an exponential function is going to be the open interval from 0 to infinity. If we think of our typical exponential growth or decay functions, the range of those functions would be like this. Now, as a result, this lets me know that both x, which would be the range of this exponential function, and y, which would be the range of this exponential function, will both only go from 0 to infinity. So the so-called domain, or what we're doing for our x variable, is going to be simply 0 to infinity, and the range, or what's going on with the y value, is only going to go from 0 to infinity as well. So the portion of the graph that I would be talking about for y equals x squared would be only the right side of the parabola with an open circle at the origin. Now, if we wanted to, we could also figure out some points that are associated with this. For example, if we plug in t equals 0, we'll get x and y are both equal to 1. So this would be t equals 0. This portion of the graph where it heads off toward infinity is where t tends toward positive infinity. And this portion of the graph where it tends toward 0 is where t approaches negative infinity. So negative values of t are creating this portion of the parabola right here, and positive values of t are creating this portion of the parabola over here. Now again, there are lots and lots of ways to eliminate parameters. There are trigonometric identities, if you see trig functions. Please know that you can try just about anything, that as long as it's mathematically valid, it can work.